Hello guys, welcome to Ramta Solutions. Today we are still continuing with electrostatics. We are still continuing with examples. Now, today's example, at this moment, it says calculate the electric field strength E at point X due to the other charges. Okay, due to the other charges. In example 8, we looked at electric field strength on point X due to point Y. Remember? So it was, I think it was 30,333,33 Newton per Coulomb downwards. However, I'm still going to calculate it even in this example. Okay? So now the question says we must calculate the electric field at X due to charges Y and Z. Right? So let's get into it. So E, let me use a different color, not this one here. Let me use black. So electric field at X due to Y is KQY over R sub XY squared. Now what is K? It is 9 times 10 to the 9. And what is the charge of object Y? It's 3 nanocoulombs. It's 3 nanocoulombs, so it's 3 times 10 to the negative 9. The distance is 90 millimeters. So milli means 10 to the negative 3 all squared. And what is our answer? Let's see. In fact, it's 3,333,33 Newton per Coulomb downwards. Right? Let me explain why I'm saying downwards. So the charges on point Y, right, are positive. As you can see, object Y is positively charged. Now, when it's positively charged, it means it'll be the direction is that it's moving towards point X. Hence, we're saying the direction is downwards. Now let's look at point Z. Electric field at X due to point Z. So it will be again. So this is electric field at point X due to at object X due to point object Z. It's K Q sub Z over distance XZ squared. Now again, K is 9 times 10 to the 9. And our charge is still 3, which is 3 nanocoulombs. So it's still the same. However, the distance changed here. The distance is 110 millimeters. 110 millimeters. So 110 times 10 to the minus 3 squared. Now let's get our electric field at this point. It is 9 times 10 to the 9, 3 times 10 to the minus 9 over 110 times 10 to the minus 3 all squared. Now, this is 2,231,40. I'm going to round it off. It's okay. Or maybe let me not round it off. So this is 3. So, 40496 Newton per Coulomb. Now, in which direction? So you look at object Z, it is positively charged from object Z to object X. It means the charges will be moving to the right. Okay, they will be moving to the right, which we can say it's okay. It's okay to say right. I guess it's okay to say to the right. All right, it's okay to say to the right, and sometimes it's also not. Sometimes it's also okay to say south in the same way as right is east, while here it's also okay to say south. Okay, it's okay, whichever you're comfortable with. So now, as you can see, the net force is basically not in this way. is basically in this way. Can you guys see that? It's basically one is going to there, one is going down, and the other is going to the right. Can you see that? So to find the net electric field, it must be somewhere. It must be here, right? It must be here. So this must be E net, while this is E of x due to z, while this one is E of x due to y. Okay? So as you can see, we must use Pythagoras theorem, right? We must use Pythagoras theorem. By the way, this one here, I should have said 9-6. Okay, it's okay. 9-6. Okay. So we must use Pythagoras theorem to find E net. Using Pythagoras theorem, let me go to the next page. E net will be square root of EXZ square plus EXY square. All right. So what is EXZ? EXZ is 2231,40496 square, while E of x due to y was 3,333,333 squared. All right. Now let's find it. Let's get into it. 2231,40496 squared plus 123 and 12345 squared. Okay. So our answer is 4011,27, right? It's 4011,27 Newton per Coulomb, right? Isn't it? That is it. Yeah, that is it. Now, what we're going to do now is we're going to find the direction of the net electric field, right? We're going, in other words, I'm trying to say we're going to find this direction, this theta here, okay? We're going to find this theta here. So when you look at this triangle, it's basically like this. So this is EXY, this is EXZ, and this is E net. Okay, so it's up to you which ratio you're going to use. You can choose to use opposite over adjacent, or you can choose opposite over hypotenuse, or adjacent over hypotenuse. It's up to you. However, I prefer using these two, which are going to tell us that we're going to say it's opposite over adjacent, meaning we're using tangent. Okay, so to find the direction, we will say tan theta is equal to EXY. Okay, it's EXY over EXZ. Alright? Okay, so this therefore means theta is tan to the minus 1 of EXY over EXZ, right? Which is tan to the minus 1 of EXY was 3333,1,2,3,4 over, other one was let me check, it was 2231,40496. Now let's find our answer. So we have, let me calculate it. Okay, over 2231,40496. What is our answer? So our answer is 56,20 degrees. Okay, therefore what it means is that remember the question was saying we must calculate the electric field at x due to the other charges. Therefore, the electric field at x due to other charges is 4011,27 Newton per Coulomb at 56,2 degrees from the x-axis, right? So all clockwise, okay, from the x-axis, okay? This is how you calculate it, and you are sorted, okay? This is it. So otherwise, you can also say it's a negative angle. It's also okay. Nothing wrong with it, okay? You can say it's a negative angle, or you can say it's 360 minus whatever. It's still okay, okay? But for now, we will say it's 56,20 56,20 to the what? To the x-axis. But be careful, this one here, when you say to the x-axis, you can either be this way, or you can also be this way, right? So you must be careful, right? You must be careful, but it's okay to leave it like this. This is how you find the direction of your electric field. So I was saying, sometimes if you don't feel comfortable leaving it here, you can say E is, I think we said 4,011,27 Newton per Coulomb at 56,20 degrees to the horizontal, right? To the horizontal axis, right? To the horizontal axis. It's okay to leave it like this. However, do also note that your angle is here. So if you're doing mathematics, in fact, you are doing mathematics, you are aware that this is a negative angle because you're moving clockwise, all right? So whether you say add minus 56,20 degrees to the horizontal axis, it's okay. Or whether you say maybe, let me say 360 degrees minus 56,20, it's also okay, all right? It's also okay, as long as you understand what you say. All right, guys? So with that being said, it's a wrap, and I will see you in the next one.